the deadbeat response, consider the discrete LTI system such as this system. You have the G and the H with the input about the UAK and the steady space representative of the xk plus 1. When the UAK, as you saw the previous slide, is equal to minus kxk, not xk, then the closed loop system become xk plus 1 is equal to j minus hk xk. And obviously, so you can find the xk is j minus hk power k x 0. Then to have a xn equal to the 0, this must be by the nilpotent is g minus h k power n will be equal to 0, this matrix. We will solve the one exercise. To obtain a deadbeat response, all the eigenvalue of the closed loop system have to be equal to 0. As we said, for the single input, single output, the denominator, the pole, is equal to the 0, and for the multi-input, multi-output, the eigenvalue of the matrix is equal to the pole of the system. If the eigenvalue of the G minus HK are chosen equal to the 0, then there exists change of the basic P, such as, if you remember, the P minus 1 G minus HP, P is equal to N. Since this you can rewrite by the P inverse of the G minus H K N P, this is equal to N power N is equal to 0. We will not go more detail about how to prove this one. We solve one exercise and you will see how this response can be react. Consider the xk plus 1 is equal to jxk plus h uak, and the g is equal this matrix, h equal here. Find the k or gain a k to have the deadbeat response. Deadbeat response, if you see the system is a controllable, we check the controllability, then that means u is equal to minus kxk, then the closed loop system is equal to g minus hk is equal to the xk plus 1, and you have the 2 by 2, that means k, you have the k1 and k2. You will find the zi minus j plus hk, absolute value of here will be z2 plus k2, z minus 1 plus k1. They said you have a deadbeat response, that means both of the pole will be on the origin part, will become z minus 0, z minus 5 equal to the 2, and these two equations should be equal to together. You can find the k1 and the k2. Pole placement method and the deadbeat response. Pole placement method, they give the, or you choose the pole. In a deadbeat response, the two pole will be in origin part. The rest of the calculation will be same. Again, define gain the k to have the deadbeat response. Now for me the g is a 3 by 3, that means you have the k1, k2 and k3, and easily you can find your system is a controllable, and or you can use the previous formula that we find. You find the a3, a2 and a1, because this one become a3, this one become a2, and this one become a1. And here, if you put in the formula, becomes z minus 0.5, z plus 0.5, and z minus 0 equal to z power 3. You can find the mu1, mu2, and the mu3 here for us, because the deadbeat response all will become 0, and you can find the k, mu3 minus a3, mu2 minus a2, mu1 minus a1. You can find the k1, k2, and k3. Or you can do the same thing. Absolute value of the zi minus j minus hk is equal to the z power 3, and you extended the equations, and you find the k1, k2, and 3, or you can directly solve by this formula. Now we go to observability. If you remember, observability is you have the system here and you have the sensor. Anytime you know about the state variable about the system, I can say all of the state variable. Imagine if you're in the car, if you have a position and the velocity, in each time you can measure about these two states. But you can see another state such as the temperature, but is not very important for me for this system. I can change my definition of the observability all critical known state variable of the system. Observability of the system is estimate the state variable of the system. I can wrote something here is very important to understand better. If you have the system x dot equal to ax plus bu, this can transfer to the block diagram about the b, and here you have the sum plus plus. Here you have the integrator x dot, and here you have the x. Here you have a matrix about the c, and you go to the output. Here x will be multiply the matrix of the a. Sum of this will be my x dot because it's ax, and here is a bu is the output, and the y equal to say x become my output of my system. This is my system. Observable, that means you estimate about the x dot. I can set the x hat. X hat, you can take the integration. Here become x hat. You multiply by the matrix about the c because I want to find this one. X hat equal to a x t plus b uat by the same input, and I add something here to correct about my system. Okay, you have the matrix about the a here multiplied by this become x hat my system. This one multiplied by the bu and the same input. This is the estimation about the state variable. I need the correlation matrix that come from these two. If these two outputs should be minus from each other, multiply the sum coefficient, the name is L, and they come to here. I can add this one plus L via t minus c x hat t. This is my system. This part is my system. This part my observable or estimation about my x dot. Okay, here they said in the discrete time, the previous slide I used by the continuous time. Here discrete time become xk plus 1 become jxk plus huak,yak is equal to 6ak. By the same input and the output, you can estimate about the x hat k. How? This block or observable exactly the same as others. think I wrote it